Einen wunderschönen Montagabend zusammen. Have a nice Monday evening. Thank you for joining in, Steve Riley. Ich habe es euch letzte Woche schon angekündigt. Wir machen diesen Februar so ein bisschen Varroa-Resistenz Februar. Letzte Woche Stephen Martin, diese Woche Steve Riley. Stephen Martin, wer es sich angeschaut hat, nähert sich dem Thema Varroa-Resistenz sehr wissenschaftlich. Er ist weder Imker noch Bienenzüchter. Dafür guckt er sich sehr detailliert die Biologie und die Zusammenhänge rund um Varroa-Resistenz an. Steve Riley macht genau das Gegenteil. Er ist Imker und unterrichtet auch Imker und koordiniert auch einen Imkerverein. Hat gerade ein Buch geschrieben und sein Vortrag wird, genau wie Stephen Martins Vortrag auf Englisch, sich darum kümmern, wie wir als Praktiker Varroa-Resistenz in unsere Bienenvölker bekommen können. Er wird den Vortrag in 2 Teile aufteilen. Fragen und Antworten werden wir jeweils nach einem solchen Block durchführen. Und ich freue mich jetzt sehr auf das, was da kommen soll. Hello, Steve. Thank you for joining in. I just explained a little bit how we will proceed this talk. Introduced you as a practical beekeeper who actually has beehives and knows how to talk about bees and does a lot of teaching for beekeepers. Is this correct?
Yes.
And perhaps you can explain a little bit more, but I think you will do an introduction where you work and where you keep bees in your presentation. So I would say just let's start the presentation and you will have your first half session.
Thank you very much, Ludko, and good evening, everyone. Thank you very much for joining. As Ludko said, this is a follow-on session from Stephen Martin's last week, where he talked about the underpinning science behind Varroa-Resistence. And I'm going to not talk about that too much, just a brief appraisal of that from a beekeeper's perspective. And then we're going to talk about more practical issues about how to observe these traits, which are very easy to do. Everyone on this call will be able to observe these traits by the end of the session and know how to monitor for them and select these bees. So let's jump in. So this is where we are we're in the southeast of England, just south of London. We run in our club about 130 colonies now without using miticides, and we're in our 8th season. So we now have a very good stock of Varroa-resistant bees, which do not need treating and look after their own mite populations. We're pretty normal beekeepers. It's typical managed beekeeping with some inspections, some artificial swarming, some honey being taken off. And the area we live in is mixed, urban and rural. Again, nothing unusual. We have a few feral colonies around, not many, but they're really helpful. And what we've been doing, and I think we're probably the only club in the UK at the moment who is doing this, is actually selecting for these Varroa-resistant traits. So we'll show you what we've been up to. So we're going to kick off with a beekeeper's view of what Varroa-resistance is, and then some ideas about how to get started, including monitoring in particular, some of our own case studies. So we do read a lot of scientific research, but if you're making judgments on your own bees, I think it's better to have done some of your own research as well, just to prove it to yourselves first. And then how to produce these VRBs, Varroa-resistant bees, working as a club. or small groups has been very beneficial for us. So we'll just try and pass on some of the practical learnings from that. And then not everything goes right with beekeeping, as we all know. So some lessons learned, which will hopefully shortcut some of your own learnings. Right, so this is our definition of Varroa-Resistence. It's very simple. There's a lot of what we'd call slightly flaky terms out there, like Varroa tolerance. No one's quite sure what they are. So we have quite a definite description. So it's the ability of honeybees to manage their own mite population without any involvement by the beekeeper. So there's no biotechnical methods involved, like queen frame trapping or caging. There's no drone culling. There's no shaking lots of sugar through the bees. This is finding bees that can do all of that. So it's the final solution to Varroa, and it's a permanent one, because what we've done is to mimic the actions that bees have naturally carried out when you leave them in the wild. So our learnings have come from understanding naturally Varroa-resistant colonies. So this is a bit of a summary really from last week and how we see it. So there are 3 phases to Varroa-resistant. The first phase is looking for Varroa families in worker cells and infected pupa. This is worker cells rather than drone cells. For some reason, there's very little hygienic activity against Varroa in drone cells. We see a little bit of it, but not very much. The second part of it is the removal of infected pupae, which prevents the Varroa from reproducing, and we'll talk a bit about that in a minute. And that, in effect, gives you low levels of mites and low levels of associated deformed wing virus. And that's it. So this is how we teach it at our training apiary to our first and second year beekeepers. So the search process is looking for cells which have been opened at the pink to purple-eyed stage, and we'll explain why that's important. And you can see that quite clearly on the screen here. And there's an interesting one there. It's usually a cluster, a small cluster like this of these cells which are opened. And the thinking is that the chemical odors that are coming up through the microporous cell cappings just get wavered around. And the effect of that is the bees sometimes inaccurately open the wrong cells, and then they later get recapped. So this is opening cells and recapping cell goes on an awful lot. There's another cell there. You can just see the cocoon coming through underneath. So that's only partially opened at the moment. And we talked about removing the pupa. Once the pupa it gets removed, the Varroa mites or the family inside all die, or except for the mother mite, she escapes. But you can see this is a picture of that happening again. It's at the pink to purple-eyed stage, which is really the key to it. So why the pink to purple-eyed stage? Right, this is the most important slide in terms of the biology. And again, I think for us beekeepers, we can all understand this. So this is the 12 days of worker brood that it's when it's sealed. So the mother mite has gone in just before it's sealed, sometimes up to 48 hours before. She hides upside down in the larval food and then is released once the larva has eaten that food. Then the cell is sealed. She then creates a feeding hole and her oogenesis, her egg laying. So she then goes into egg laying mode, firstly laying a son after about day 3, and then a series of daughters from around day 5 with about 24 hours apart. Now the arrows there show when the son and the daughters are sexually mature. And it's not until they're sexually mature that they can mate. And the mating takes place there. So at the earliest, it's going to be around day 10 with the youngest of the sisters of the brother there. But you can see the pink to purple-eyed stage is around day 6 and 7. So the interruption stops that mating taking place, and the removal of the infected pupa at the pink to purple eye stage means that all of those offspring die. And there's another benefit to this as well, that the mother mite only has 2 to 3 attempts at reproduction, and then she becomes infertile. So naturally, Varroa-resistant colonies, the ones on the right of this graph, have about 45% of their mother mites are infertile. So they're a spent force. They've been mostly interrupted by the bees in their reproduction, and they've not produced mites. So you don't get this massive mite buildup that you see in a lot of the graphs. Those are from mite susceptible colonies. You get a sort of bumping along effect because the bees are taking on the Varroa. Right, so how to get started? So the key is monitoring. This is all about the re-engagement of beekeepers over this problem. We've backed off for 30 years now, and what we've been thinking about is when to treat, when to use biotechnical methods, and we've sort of forgotten about the interaction of the Varroa and the honeybee, and we're going to jump back in, and it's fascinating. So we get to learn a huge amount. So the monitoring is all about finding bees with high defenses to Varroa and also identifying those with low defenses to Varroa. And the key thing is obviously, once you find the high defenses, is to select for those. And as important is to deselect the ones with low defenses. We need to get rid of those bees which are mite farmers. So monitoring, you can't just do once a year. Some of the British teaching was you monitor in the summer and try and find out what your mite levels are like, and then you either treat or you don't. But it's far too late then. You need to monitor over a period of time, a minimum of 4 times a year, and we do it more regularly. And once you get started down this route, it just becomes part of your normal beekeeping. You need a consistent approach. We'll show you ours, and it's that monitoring which is going to inform your selection decisions going forward. So the monitoring is straightforward. So we have an insert board that goes in underneath an open mesh floor. We got sold these open mesh floors for the last 30 years really in the UK, and they're pretty hopeless really. And bees don't like open floors at all. But if you put a monitoring board underneath, you get a laboratory. You get so much data coming through. It is fascinating, and we'll show you how we use those. So it's a very simple technique. Don't underestimate it. And people will laugh at it a bit, but actually it's crucial in terms of understanding Varroa-resistant traits. So I have a garden linked apiary, so it's easy for me, and I will look at them every 2 to 3 days or 2 to 4 days. We have a project and a club not too far from us where we've helped get started, and they look at their boards once a week. One of my colleagues, one of the founder members of our project, she just puts a board in for 3 days a month, and that gives her a rough guide. But the other win about using this Varroa board is at the same time you start to see chewed out exoskeleton. So the exoskeleton, when those bees, we saw the picture of them chewing out at the pink to purple eyed stage, bits of the exoskeleton will fall down. Some of it will be flown away, but some of it falls down through the wax combs, through the open mesh floor, and there it is on the bottom board. And that gives you an awful lot of information. You know that the bees are in there and taking on the Varroa, and they are rejecting unhealthy pupa. So why did we use the Varroa insert board? Well, firstly, it just gave us that all year look at what was going on, and we've written a book on this and tried to give a feeling for all the seasonal changes in hygienic behavior and the things that you can observe. That gives you January to December. It's non-invasive. It takes 30 seconds to have a look at your boards, and it's a measure of the whole colony, not just a small part of it or small sample. You get this research win of seeing the chewed out pupal exoskeleton, and that helps you understand the seasonality of hygienic behavior. It does need some interpretation. Okay, so this is a bit of a new game for most of us beekeepers, and we've written at length on this so that people can tune into what we think we've understood. We did think about sampling. So this is like taking 100 bees and shaking them around in alcohol or detergent, or 300 bees. But the limitations to that is that one, it's invasive, so you have to be in the hives doing it. It tends to be March to September only, because that's when we're able to have a look in the hives. It is just a measure. It's a small measure. It's a small sample, so it will be badly wrong from time to time versus a whole colony. And then it misses out on this other bits of information. So you talked to most professional scientists or commercial beekeepers, and they've never heard about looking for chewed out pupal exoskeleton, because all they've been doing is copying what the scientists do. Now, the scientists love a sample because it gives them a nice percentage, so they get quite excited about that. They like the exact amounts and the percentages it gives them, but the percentage is always going to be badly wrong. And all we're looking for as a guide really is high, medium, or low. But it doesn't give this chewed out pupal exoskeleton. It gives you no other insights into the hygienic behavior either. But like the insert board, if you do sampling, it needs a level of interpretation, because mites do hang out in the brood. So here's this is an example from earlier this year. I hope you can see that okay. So in my apiary from earlier this year, you can see the wax clippings. You know roughly the size of the cluster and where it is. This one happened to be right in the middle of the hive. The mite count's been low. It's been 1.4 there over the last month, so it seems in good shape. And there it is on the board. I've blown it up. An egg. So the queen's laying. Great news. So we found some good news at the start of the year. The queen is laying. And you often do find a few eggs on the boards around this time of the year, or around early January. And it's almost as if the queen overlays, or she lays too widely and they get thrown out. We don't know why they're not eaten. The eggs are thought to be eaten for protein, but we do see them on the board. So it's just a good sign that there's activity there. And here's a different hive on the 16th of January. So we're beekeeping through the winter here, which is great. You know, that awful time in the winter when you get a bit itchy and you're not relaxed because you're missing your bees. So this is an opportunity to do winter beekeeping. There's no bees to bother you, and you can just have a look and see what's going on. So you might be able to spot something on the middle of that board, but I'm going to blow it up for you. There it is, pupal exoskeleton. And the bit of antennae there just to the top. Can you see that all right? That's a bit of antennae. So that's the first bit that gets chewed out. And there's some proboscis and just the top of the head there. So that tells us a number of things. It tells us that that the queen is laying. So what a great start to the year. It also tells us that the overwintered Varroa have tried to reproduce and are being taken on by the bees already. So you're not getting this big run up at the start of the year of mite building up at all. You're getting a pretty flat line is our view. So we also know that the queen was laying about 14 days ago. We know that because we know the timing of eggs to larvae to sealed, and we know that the chewing out is at the pink to purple-eyed stage, which is about day 6 or 7. So the queen started laying here on around the 2nd of January. Good news. And then on the same day, some bits of pupa in another hive in the same apiary. So we're seeing this in all of our colonies at the moment, and it's just, we're beekeeping without doing anything invasive, and we're understanding what's going on. Keep your monitoring simple and quick. I just take a piece of paper down with me, and you can see there 8+1 was one of the answers, and so that's 8 mother mites. Those are the dark ones. You don't count the immature ones. They've probably just been cleared out as immature mites. The 1 is an immature mite or juvenile mite, and then the P is for pupa exoskeleton. Simple, 8+1 P. And then you convert that to a daily average.
Oh.
We have a hive record card where we just include this information here, and then we ask the question of whether this queen is a good breeder or not. Is she uncapping and recapping and chewing out her? Are her nurse bees doing these things? And so it just becomes part and parcel of every inspection and how we think about the bees. So we've really engaged with the monitoring. We're now got a way to not to quantify, but to get a good feel for these these bees' ability. This is a free download if anyone wants to help themselves on the Westerham beekeeper site, and I think you can manipulate it to put your own names and things on as well. So do help yourselves if you would find that useful. Right, so the real benefits of monitoring, here it is. So this is a colony which shows mite drop through the spring, or sorry, through the winter, 3 months from the winter into the spring. And it's on mite drop on a cumulative basis. So the daily mite drops added up. And what a difference it's showing between some of those colonies there. So hive 8, and who would breed from hive 8? When we know there that it's got over 2,000 mites has dropped in that period of time. And then the other colonies which we're monitoring there have got around 500. So it's obvious, isn't it? From monitoring, you get to see what goes on. Now, just jog back to our past. In the past, we would have done everything to have kept that hive 8 alive. We would have used formic acid to reduce the mites. We would have culled the drones. We might have done what we call a shook swarm. We might have put lots of sugar in there and shaken it through. And then if we had kept it alive, we might have bred from it as well, you know, and that's what we've been doing wrong for 25 years or so in the UK, just breeding from the wrong bees. And this is what we're now stopping. Once you stop breeding from the wrong bees, you make a massive difference in your apiary. And so that you have options here. So if we had a live audience, I'd be asking you what you would be doing with that hive 8. And you get some very different views in the audience, you know, and it's with some people, it's, you know, that queen is not going to go forward. And with others, people look for a kinder solution, you know, but in the spring, what you can do is to requeen, and you must do, you know, you must get rid of that queen's genes and not let her be part of the apiary's genetics going forward in any way. And ideally, you would not want her drones flying as well. Actually, what happened to that hive is it went to a beekeeping friend of mine who lives about 30 kilometers away. So he was nicely out of the way, and he got a super of honey off the hive, and he has no shame about how many chemicals he puts on his bees. So he was happy. Everyone was happy. Everyone got what they wanted. But in the spring you should requeen. And the way we talk about it is that if you have a hive that's very aggressive or very defensive, however you like to think about it, you know what you're going to have to do. You know that queen's gone. You're not going to breed from that. And it's the same when we find something like this colony, which is very mite susceptible, has very low hygienic traits against Varroa. You cannot keep it going. It's always obvious to us, and monitoring is the key to that. So here's the summary. It says all that beekeepers need to do to find Varroa-resistant traits. So firstly, look for uncapping. You know that the search is going on there. A lot of people have seen this in their hives, and in the UK, we used to call it bold brood. We had no idea what it was, but it was called bold brood. And if it's in a straight line, it will be for wax moth. So bees know how to uncap. It's not a new thing they've been doing. They'll uncap for chalk brood, for wax moth, and they'll also uncap in clusters for Varroa. So look for uncapping. Secondly, look for chewed out pupal exoskeleton. You know that the whole interruption to the Varroa reproduction has taken place when that pupa is chewed out. We can see those. These are easy things for us to see and to monitor for. That interrupts the Varroa reproduction. It gives you low mite counts, and that's the third thing to monitor for. And with low mite counts, you get low levels of deformed wing virus. And that's it. That's monitoring for Varroa resistance. Right, we're going to jump into a couple of case studies. This is our own research, which we're going to share with you, and then we'll stop and see if there's any questions, which should be about halfway through. So this is a colony. It's on what we call a British national brood box. The bees are restricted to just one brood box, and the British national, I think, is about the same size as a DN, I think is the equivalent that Ludger has helped me, if that helps you in terms of size. So it's not a huge box. And then it's been a good season for honey that year. So we find that there's no issues with honey production if that's something that's interesting for you. Whilst these bees are doing a lot of work on hygiene against Varroa, these nurse bees that are working, and when there's a very strong nectar flow, all the hygienic behavior stops, and they just focus on getting these stores processed into honey. The setup here, we have a board in underneath an open mesh floor all year round. Okay, we don't believe in ventilation. Again, it's something that's a myth that's gone around in the UK. Bees just are used to having one small hole to work all of their oxygen, CO2, and temperature requirements. We use insulation. You can't see it very clearly here, but cork on the sides of the hive and on the top as well. Insulation is helpful. It's not the key to Varroa resistance, but it helps their environment. They don't have to manage temperature changes so much. The bees are openly mated and have been for a long time now. They've got darker, interestingly, over the years, but they're still hybridized. So there's a bit of a mixture. We've had a lot of imports into the UK. And we only breed from our own queens in the same apiary. So I breed from the mothers, the grandmothers, the great-grandmothers. Right? They're all openly mated, and what we find is the Varroa-resistant traits come down the queen line. And I know this from other colleagues in our club, but also in different clubs in the UK. So it's a very heritable trait down the queen line. So once you find these traits, just breed from her and then breed from her daughters. They try to swarm once a year. They're not frequent swarmers, and we try to artificially swarm them, and we'll show you how we do that and how we use that as a time for increase. And they usually produce a surplus of honey, and we tend to leave them a whole super of honey. So that second box is left for them for winter, and we'll explain why in a minute. And they're pretty pleasant to handle most of the time. That I would call them educational bees. That they will tell you when you've had enough of you, which I think is quite a useful trait. So this is an analysis of the mite drop and the hygienic behavior correlated with the brood availability for the full year for that colony, which I'm going to break down for you to explain and point out a few things. So there's your frames of brood in green there. We've had to guess a bit for the late winter and early spring. And you can see there in May, there was an artificial swarm, and then almost a broodless period. And then the new queen starts laying, and then she lays vigorously up to 11 frames of brood in that box, and then it gradually reduces into winter. So I think that's a pretty normal pattern for most bees. And then there's a broodless period, which in our club or in this area is, I think, early December or perhaps end of November, depending on the weather. So just overlay the mite drop per day in the yellow there. So so it starts off at 5 a day roughly and goes down a little bit. And this is where you need just to re-engage a bit and interpret. So when there's new brood, what you should be seeing is mite drop falling, because the Varroa will go into the brood to try and reproduce, particularly if they've been overwintering on the bees. But still, it's a very low level. And then we have drones being laid end of March, around that sort of time. And we always get a pickup in the mite drop after the drones, and they start after the drones start to hatch, because there's less hygienic behavior against the drones. And we also get a pickup in mite drop during the broodless period, and you see a mite drop there of about 170. It's not huge. It's not the solution, and it's not Varroa-Resistence, because that happens in all colonies, whether they're mite susceptible or not. So, but it is a beneficial health effect for the colony to have a brood break, and it is healthy for them. So you've seen a 170 drop in that little spike there, and I can point to that there. And then we get, this is an interesting sign. So the Varroa, they've now got 11 frames of brood here as the new queen is laying. So the Varroa move back into the brood. And this is a time, certainly in the UK, that we get told to have a think about what our mite levels are like. Now, how are we going to get a good judgment on our mite levels? Because the Varroa are all going to be in the brood. That probably 80% plus will be in the brood trying to reproduce. And so if you take a sample at that point in time, you'll get no indication at all what mite levels like. And similarly, you should see a fall in the mite drop, because the Varroa are in the brood there. So, and then we get this big spike, which frightened us when we first started and didn't understand it, and we now have a much better idea of it. And the insert board has enabled us to sort of have a think about this. So let me just move on a slide, and we'll talk a little bit about that. So there it is. So the cause is a build-up of Varroa during the summer flow. So we have a very strong nectar flow in July into August, and when that happens, there's less hygienic behavior in the colonies, and we see that. You don't see so much uncapping or chewing out going on. So and the reason is the colony is turned into a honey factory, that it's focused on getting its stores in, and all other behaviors are subordinated to getting those stores in. And then what happens is that the brood starts to reduce. So you can see the brood frames there going down from 8 to 7 to 6 to 5. So there's less places for the Varroa to reproduce, and you can get multiple foundress mites, mother mites, going in to try and reproduce. Now, once the colony has got sufficient stores, it goes into what Torben Schiffer described to us as stores secure mode. So they know that the kitchen pantry is full. They have sufficient honey, and often this moment is typified for the beekeeper when they pick up a frame and it's got loads of propolis all over it. They're thinking ahead. They're thinking about preparing the brood nest for winter, and there's an awful lot of hygienic behavior that goes on as well, which we'll show you on a slide just coming up. Now, there's 661 mite drop there. And if you think about this in an emotional sense, as we used to, you would be looking for treatments or any other ideas you had at that stage to try and get rid of those mites. So let's just understand why this colony gets through just with no emotion. So here is a typical brood frame. This was taken last year on the 3rd of October. It's actually in a nuke, but it's typical of the size of a brood frame at this time of year, starting to get smaller. Now, on that brood frame, in that yellow area there's 1,100 cells. And so if you assume there's the same amount on the other side, you've got 2,200 frame. Now, in September, we had 5 frames of brood, and then 3 frames in October, and then we're going to estimate there was 1 frame of brood in November. And that would give you about just under 20,000 bees. And these are your winter bees. These are the ones that have to survive for 6 months to take you through to next March and April. Now, there's the perspective for your 661 mite drop. So there's no need for this sort of emotional outburst that we are driven to, and worry about putting miticides on or doing some biotechnical measure at that point in time. These bees have already got this under control, and that's why this colony will get through the winter as it did very easily. The next slide just needs a little key. There's the green P is for pupa exoskeleton, which is what we can see on the picture there, and a UN is for uncapping. So we see uncapping during inspections. Once you start seeing uncapping, you just can't unsee it. You see there the pink to purple-eyed stage, and you know exactly what's happening there. So there's the full year of the hygienic behavior that we've been able to monitor. So we have this brilliant start to the year where we see the pupa there, and we know the queen is laying, we know that the varroa is being taken on by those bees already. And then we get inspections starting around here in the spring, and we're starting to see uncapping taking place. So that completes our observation. We know the bees and the nurse bees, they are doing the right thing and taking on the varroa. There's an artificial swarm here, so you're not seeing, we're not monitoring, we're not seeing very much activity there. And then the new queen starts laying here. Now, she doesn't own the hive initially. Her nurse bees will take a couple of months to become an expression of her. And there it is, the new queen's offspring. They're chewing out pupae and uncapping, just like her mother. And this is the heritability that we see, and why you want to keep the queen's daughters and daughters and daughters. And then inspections are finishing here, but we're still seeing this chewing out. Now, this time here, you might have 2 or 3 mites, mother mites, going into a cell. That the detector bees that Stephen Martin would have talked about last week, it's an easy target for them. The smell of the Varroa offspring coming through or infected pupa coming through is easy for them. So you see a lot of pupa being chewed out at this time of year. And in fact, there, just at the end of the year, there was some pupa here at the end of December, which suggests that the queen, in this case, started relaying again in the middle of December. So you get to understand the rhythm of your colony just by this simple board. And there's the whole chart. Okay, we've gone into a lot more detail in the book, but hopefully that gives you a feel that and some confidence that you can do this. We went a bit further in trying to estimate, based on the mite drop data we have, of what the direction was of the Varroa level through the course of the year. Now, the concept is that at the start of the year and at the end of the year, the Varroa level should be roughly the same. And what happens in mite susceptible colonies is at the end of the year, the mite level is higher. So it has a higher starting platform, and then it goes on and gradually overwhelms the colony. So at the start of the year, we think that it's the green line we're focused on here, the green dotted line. We think there's hardly any growth in Varroa at all because the bees are taking on the overwinter Varroa. Then you get some growth because the bees go into the drones, and there's less hygienic behavior against the drones. There's a slight fall at the time of the artificial fall, and then you get strong growth again through the strongest part of the nectar flow. So when the honey is being made, when the nectar is being processed into honey, there's less hygienic behavior. So you get growth then, and then that falls away rapidly in the pre-winter spike, as we call it. So, and then you get this fall away to the end of the year. So interestingly, that pre-winter spike of 661 mites was over half of the total mite drop for the whole year. So it's a massive pre-winter clean out. And when you first see this, you either have to trust what you're seeing, having read the book, or you have to sit on your hands and hold your nerve. Right, second case study about uncapping and chewing out of pupae. So we wanted to try and prove this to ourselves, and we're just trying to think of simple ways to do it. So we took a picture of 2 bits of brood 24 hours apart, the same the same bit of brew. So check for the queen, gave the frame a bit of a shake, apologized to the bees, and took a picture. And you can see on the left there, on the 16th of May 2022, there is a nice cluster of uncapping going on, pink to purple-eyed stage. You know, we're getting to see this pretty regularly now. Now look at 24 hours later. Look at the differences. Can you see those? We've marked them on. So further uncapping in that 24 hours, we put in the lime green. There's a lot of chewed out pupa there. Look at that. Much more than we thought was possible. We just did not know this level of activity was going on. And then you've got one in the blue here, which is being recapped. You see that? There it is, uncapped there, being recapped. So this uncapping and recapping goes on all the time and is a real feature of the whole process. And in fact, Ralph Buchler, who I understand is going to speak to you in April, has seen the record for this, that he saw in an observation hive, the same cell was uncapped and recapped 17 times. 17 times. So this is a remarkable amount of activity going on in the dark of the hives. We had no idea about it. And we knew there was some level of activity going on because we could see it when we're looking for uncapping and chewed out pupa on the bottom boards, but not at this level. And if we look, if we add in the activity from the first day as well, there was a lot of cell cappings where we could see they'd been disturbed. So they'd already been opened and closed again. Sometimes it's not very obvious, and sometimes it's really easy to see. I'm not sure the photograph does it justice, but there was a massive amount in total activity on this frame. Now, is that typical of all of our worker brood? I suspect it probably is, actually, but you don't want to be going in and taking pictures 24 hours later too often. It's not very nice on the bees, but it was a fascinating bit of research and something that again everyone can do. So that's so before we get on to this section, I was going to stop. Let me go back one. I was going to stop to see if there are any questions, Ludger, and happily take those, or else we can go on to the end. But up to your audience.
Okay, do you hear me? I just closed my microphone not to interfere too much. Do you hear me?
Yes.
Okay, thank you. I'll just have a look. There was a question. There was a dashed graph dashed line in your Varroa-Resistenz graphics. This question was put before you have shown the slide with the total mite infestation. So it's probably the line of peas he was talking about. Can you explain this?
Can we just go back to the slide? Let me see if I can go back to it. Sorry if this is it? Was it this one here?
It was a little bit earlier, but
okay.
Probably
this dashed line here.
That's possibly the line he was talking about. Yes.
Yeah. So all I'm trying to say here is, look, in this spike, there's 661 mites.
Okay, that's just
so the mite drop.
The period.
The mite drop in this period here. There was 661 mites. Yeah.
That's accumulated mite drop in this time.
Yeah.
Okay.
In that time, yeah. So that was roughly about half of the total mite drop for the whole of the year.
Okay. And then there's a question about the bottom board you are using. How is the mesh you have in the hives in the bottom boards constructed? Because they somehow doubt that they can find those exoskeletons.
Okay. So it's basically it's 4 pieces of wood with which is the bottom the bottom foundation of the hive, and then it has just a mesh going across the whole of it. I haven't got. Let me just hang on a second. I'm going to try and show you from the book here. I put a very simple picture of it in the book. Do you not use bottom board open mesh floors at all?
We use them regularly, but perhaps there is a different mesh in the construction. It's difficult to see. I can't.
So you can see straight through that to the floor, and that's because there's a mesh in the way.
It looks pretty thin wired compared to our meshes. Perhaps that's a difference for the ability to monitor the exoskeletons.
Page 35 when you get the book.
Actually, it's something about 40 with shipping. Another B-Books charges €12 for shipping.
Really?
Yes. But I ordered just to read your books.
I'm sorry to hear that. Yeah.
They probably can't do it any cheaper.
Well, we'll have to wait for Ludger to do the German translation for you.
Don't promise anything. Okay.
Any other questions, or should we
yes,
move on?
There's one more general question about the heritability of the VSH trait. You mentioned that this is pretty high. Other sources mentioned it's a recessive trait. How does this fit together?
Okay. Well, we firstly we're not geneticists, so we don't know. We couldn't say that whether it was a dominant recessive or additive trait. But what the scientists have said is not that it's recessive at all. So if you go back to some of the best work that we tuned into was very well funded work at the USDA. So the US Agricultural Department. They were given $10 million and told to solve the problem. And they came up with some early work. This is 25 years ago now, which said that the traits were additive and they were polygenic, which meant that they come from different parts of the bee's genome. So they were not recessive. So additive genes means that the more that there are there, the more they'll be expressed. So the latest bit of work we saw on this was last April, so just under a year ago, which came out of France. And the ability to understand the bee's genome is improving all the time with technology, but it's still incredibly complex. And the research showed that the Varroa-resistant traits came from 60 different parts of the bee's genome. So very complex, and any breeder who tells you they're going to find genetic markers, good luck. It's going to take a long time if they get there. But in the meantime, you just need to know that it's to breed from the queens that have these traits and keep the daughters, the granddaughters, and the great-granddaughters. Now, that's exactly what we've seen. We see that through lots of our colonies in the club, and one of my fellow beekeepers up in the different part of the UK, who's a commercial beekeeper, sees exactly the same. That the traits come down the mother line, even with open mating. Now we saw that from the start, and what we've also seen is the traits generally in the colonies in our apiary have stabilized since we started to influence the drone area. So when you first start, you don't have a great influence over the drones in the area, but you will start to, and And that's what seems to have worked. So, so the trait is additive, it's not recessive, and it's not dominant. It's additive, it's polygenic, which comes from different parts of the bee's genome, and is very much passed down the queen line. And we tell you that with the certainty of having done it, okay? We're not going to quote research papers at you and scientists. And the people who will tell you that it's something different are usually commercial breeders who tell you need instrumental insemination. You know, and I think it's completely wrong. And you know, we're way ahead of these guys in having these bees, and that's with open mating. And the other interesting thing is that the person who really got this all this started was John Harbaugh and some of his colleagues at the USDA. He was copied by some of the European breeders, which we're now getting their bees from. He is just about to change to go to open mating to see if he can replicate the Varroa-resistant traits with open mating in a more natural way, because that's the only really sustainable way for honeybees to cope with Varroa. So that's quite a long answer, but the simple answer is it's down the queen line.
Okay. Then there is one question to your 20-hour photo slide. Could the massive activity on the board cells also be a mistake of the bees? I mean, maybe they are not sensitive enough and kept too many cells. Is there some room for improvement?
Yeah, don't be too harsh on the bees. We're still learning about what they've been up to, but they've done a fantastic job. But they're absolutely correct in the question, good question, in that they uncap too many and they make mistakes. And the mistake is probably because the chemical cue that's coming up through the microporous holes in the capping, the bees are trying to tune into. The work from Fanny Monday that Stephen Martin talked about last week showed they could smell the offspring in there, and they can smell offspring and they can also smell unhealthy brood. So the combination of the two, that smell is coming up through the cells. Now, as it comes through the cell capping, it can be wafted around because there's bees in there, there's wings going, people are ventilating, so the chemical cues come up. And the thinking is, if there's one cell, there could be 3 or 4 all around it, which are perfectly fine, and they all get uncapped because there's something not quite right about it. And then what happens is there's further investigation by the sniffer or detector bees, as they're sometimes called. And if they find the problem pupa, that one is the one gets cued out, and the rest get recapped.
Sorry for the noise. That
so
would
the
match
rest of
what Stephen Martin showed us last week about the spatial distribution of recapping. There seems also be some clustering, which he explained in probably almost the same way you explained this notice.
Yeah, and the recapping. So this recapping is typically carried out by bees which don't have the same olfactory senses, so not the same ability in the antennae to smell these problems, to smell the Varroa offspring or the infected pupae. And their job in the hive as nurse bees is to cap. And so if they come across a healthy pupa, they'll just cap it. And then you get this process of bees coming along again and going, no, I think there might be a problem with this. Let's uncap and have a closer look. Then you get this uncapping and recapping going on, which Ralph Buchler has seen. But one of the really interesting slides from Stephen's talk last week was this uncapping and recapping. It's called the recapping rate. Is seen as a proxy for Varroa-resistence in these bees. And what he was able to show in a graph with some red lines going up, it was that some of the worker cells have been uncapped and recapped. About 70% of them was probably the most, which are the bees in Cuba, which are Apis mellifera bees. They originally would have been from the UK a long time ago. So similar bees that we have in Europe, and they have 70% uncapping and recapping rate. they've got 240,000 colonies in Cuba, which are all treatment-free, Varroa resistant, right? And the same uncapping and recapping you're seeing in England. You see it in the Arnott Forest under Tom Seeley. There's places in Sweden and Gotland Island. There's places around Oslo. We've got resistant bees. Avignon in France. They've all got this uncapping and recapping going on. So it's seen as a proxy for Varroa resistance. We don't look for it. We started to get interested in it when the scientists uncovered it, but we don't look for it as beekeepers, because you don't need to know that if a cell's been recapped. What you really need to understand is that they are uncapping. And the uncapping is your search process, and then the chewing out, we can see. And as long as your mite levels are low, you know that there's sufficient hygienic behavior going on to keep those mite levels down. But it's a good question. There's definitely a mistake. There's some mistakes made, and they do correct it.
The next question, do you think that this uncapping behavior, specialized for Varroa, will allow other enemies like beehive beetle, small hive beetle, or Tropilelaps mite to be more successful in such Varroa-resistant hives?
Yeah, we don't know. Okay, we just don't know yet. I think the point about uncapping, let's just not forget this, is it stops the Varroa from reproducing. It stops the Varroa from reproducing, and then it makes the mother mite become infertile because she can only reproduce 2 or 3 times, and that's the point. So if these bees have worked out they can stop Varroa from reproducing by uncapping at the pink to purple-eyed stage, can they do the same thing for Tropilelaps? Question mark. We don't know yet, but I would be quite hopeful that will be the case. So the interesting question is, how is Tropilelaps controlled by Apis cerana, the Asian honeybee? And part of the thinking is from grooming, and the second part of the thinking is they get rid of cells where they're reproducing. So there's some very early research in Thailand which showed that. We need better research, and we need people to be focused on asking that question, finding a solution of what's going on in Asia, and then so we can start looking for it over here. It may well be the case that Varroa-resistant colonies already have gone in the step in the right direction.
Okay.
But we don't know yet. That's the reality. We may have another 6 to 10 years before we see Tropilelaps, but in that time we need to do the research.
The next question, then I will close the Q&A session for this part. In your diagram, you had an artificial swarm phase in the May, I think.
Yes.
Do you think this swarming incident is crucial for the resistance of the beehives, or do you have hives that don't swarm but still are resistant?
It's not crucial at all, no. So it's helpful to the health of a colony, but the way to think about it is that bees have always tried to swarm. They tried to swarm before Varroa, they tried to swarm after Varroa, and it's still the case in places where Varroa just turned up, that the swarming was never sufficient to stop the Varroa from taking over and killing those colonies. So swarming is not the solution, and we know that in places like, say, the Arnott Forest under Tom Seeley. There were bees there in their perfect environments, in a tree cavity, well insulated, lots of propolis around the brood area. They could swarm as soon as the brood nest was full. They weren't given extra room like beekeepers put extra supers and things on, so they would have swarmed. But we know that an awful lot of those bees died despite their perfect conditions. and we later know that only a few of those queen lines went forward. Now, so it's the queen lines which have the nurse bees with the ability to find Varroa and to intercept the Varroa reproducing is the key to it. And yes, I'm going to show you a slide actually of some mite numbers through a few years, and it shows probably our colony, which was the most successful with Varroa, hardly had any Varroa in at all, and it didn't swarm in the year that we did the numbers.
Okay, back to your slides.
Good questions, thank you. Right, how to produce Varroa-resistant bees, VRBs. So here's our protocol. We like to see our bees wintering for at least 3 years without any Varroa assistance from us, so no beekeeper involvement at all. You can't do that to start with, so you have to just find the uncapping and the chewing out gives you low levels of mite number. So you can do 2 and 3 when you're starting, but not 1. But the question we sometimes get is, well, are you missing anything? Are you just selecting for these traits? And so our point 4 is spring health. So how have they overwintered? Are they well? Are you seeing strong brood development, which you should see in the spring, and strong nectar and pollen gathering? So those are good signs of health. So we look for that, and we also look for gentle temperament as well. So you can have fairly well-behaved bees and Varroa resistance. So the two are not exclusive. This is an example apiary of how we look to produce a surplus of bees every year. So it's completely self-sustaining. There's no need to ever buy bees again, and I never will. So I bought 1 nuke when I first started beekeeping, and that's it. So here you have the honey production hives up here. They're not treated. They get evaluated through our monitoring system through the course of the year. Excuse me. We use an incubator for spare queen cells. We'll show you about that in a minute. And we establish nukes to overwinter, nucleus colonies. So these are in poly hives, so there's good insulation, and we overwinter them. They overwinter brilliantly in poly hives. In the spring, we'll evaluate those, and they'll either replace any losses we've had in the honey production colonies, or they can be sold out to other people in the area. Try to keep the bees in the area if you can, just to build out the traits. This is how we do the artificial swarms, which actually also becomes part of how we produce the queen. So when you first start your beekeeping, you get told so many different ways to do so many different things, like queen rearing and artificial swarms, and you sort of naturally assume you must learn them all, and it's very confusing. So we've tried to take all the clever things that beekeepers do out of the system and keep it very, very simple, and just try to work with the bees in what they are trying to do. So this is what we call a nuke artificial swarm. So we start to see some queen cells being made. We know the bees are getting ready to go. So we, excuse me, we give them a poly nuke here. We take the laying queen. She goes in here with 3 frames, 2 frames of brood and a frame of stores, and then there's a dummy ball. That's it. The forager bees, you can keep this nuke in the same apiary, and the forager bees fly home. Next time they fly out, they go back to the original hive. This is one of those rare moments in beekeeping where you're actually in control of a swarming situation. You know this colony over here is not going to swarm. It can't swarm. And what it's going to do is to produce beautiful queen cells from you. So you know you like this hive already because you've been monitoring it. It's fantastic Varroa-resistant traits. You've got the queen over here. You want her daughters as well. So wait for up to a week, and you will have some beautiful queen cells made for you. And these queen cells we put into roller cages into an incubator. So you can buy these cheaply on eBay. So these are a bunch of queens. So you just cut the queen cell out, pop it into the roller cage, and you get a lot of queens piping at you when they hatch. So what we like about this is that these are bee chosen queen cells, right? So we're not involved at all. And interestingly, if you take a picture, and I haven't got a picture to show you, but if you took a picture of the queen cells or which were being made, and then a week later came back to have a look at that same frame, you will not see those same queen cells. They're often taken down and they start somewhere else. So this monitoring of queen cells goes on a lot more than we appreciated. Maybe that's the next project. So we used to do grafting, okay, and we found an awful lot of the bees were superseded, and we hardly see any supersedure at all now. So we have a very simple method there of producing lots of queens. So the drones used to be seen as expensive and lazy. They're now part of our armory to produce lots of other Varroa-resistant virgins out there. So that half the genetics, we add this is a frame full of drones there. There's going to be thousands of drones going into your local area. So you can influence the local area. We give them a frame, an empty frame like this, and put a barbecue stick down the middle, just there, and they will produce two sides of drone cells for you. And this is perfect, pure wax, which is the right size for the drones, as opposed to forcing the drones to put their drone cells into worker foundation. We like the pure wax because often in foundation, you get this recycling of miticides that comes around. And these drones are going to spend the longest time in their development in this wax. And all of their semen is going to be produced whilst they're in there. When they're born, they have all their semen which they're ever going to use. So you want to make sure that it's really good, healthy wax. So we try to influence the local area with our best colonies by giving them an extra frame of drone or empty frame, which they will make into drones. We put that on the outside of the brood nest. Here's our mites per day framework. Don't overthink it. It's low, medium, and high. Okay, so we aim for roughly 5 a day across the whole year. It's never going to be 5 or under a day. It can be 20, you know, in the late summer, or it can be 1 at different times. So, but just have that in your mind. This is for a British national hive, which is the equivalent of roughly a DN hive. So if you use a dadant, then you'll need to make sure that you're thinking about a much different, much higher numbers. So it's when you're monitoring, it's of the low ones are fantastic. It makes you smile. The high ones, you know, you're going to have to take some action, and we'll talk a bit about that in a minute. Requeen them. And it's just this tricky area in the middle where you need some judgment, okay? And that's beekeeping for you. So you're going to have to use your common sense, your thoughts, your best ideas, and take it from there. So what to do with colonies with high levels of mites? Firstly, they have to go, okay? You just don't become a mite farmer. Get rid of those queens which do not have nurse bees with good levels of hygienic behavior against the mites. So in the spring, you can requeen from your best stock, and I'm sure there's plenty of experience on this call, and you know how to do that, and there are different ways of doing it. So if you do that in the spring, the new queen will have enough time for her nurse bees to take over the colony and reduce the mite load in time for winter. Your other option is to shook swarm and requeen. So you're effectively taking the mite numbers down and then putting a queen. If there's a particularly heavy load of mites in the colonies in a bad way, or you could even treat and requeen. So, but you want to requeen in the spring. If you find you've got a problem midsummer to early autumn, you can't requeen. It's too late, and it could be that they'll die in the winter with your new lovely queen, which you do not want. So at that time of year, I would reduce mites with by a technical measure like a queen frame trap, which we're going to show you in a minute. And Ralph Buchler, we learned from Ralph Buchler. Or you can just treat, and then you need to think about them in the next spring. Then don't let their drones fly, and then requeen them in the next spring. So you've got options there. And just be pragmatic about it. We haven't treated since we decided to stop, and it was like being an alcoholic and saying you will never drink again. It was a revelation, and it makes you become a beekeeper again and start thinking about the problem. So, but those are options, and just be practical, whatever suits you best. So here's the, this is a slide which just gives you a flavor for how mites have come down over the time. So the high 5 there is in the blue. This is a colony that didn't get through that winter, and the mites were too high in it. That was in 2020. The yellow is in 2021, which is the colony we've been talking about, did the full year analysis on. And then here's in the magenta, bubbling along the bottom there, it was a hive 2 in 2022, and its mite load was the lowest we've ever seen in any colony. And in fact, there was hardly any mites there at all. And they were also taking on the drones as well. So it was an interesting one, and it did not swarm, which was the example I wanted to give from earlier. So it's all about the level of hygienic behavior that's key, and the rest is just myth by people who haven't quite understood what the mechanism of Varroa resistance is all about. So I would say most of our colonies now come in between the yellow line and the magenta line, something like that. So we don't really need to monitor anymore, but we do it for research, and we're involved with trying to help the UK become a Varroa resistant country, and we're getting lots of requests elsewhere as well. So some results. Yes, when we started, it was worrying. Okay, you know, we, like everyone else, we were told if you do not treat, your bees will die, and that's what was all our training was all about. Then we met Ralph Buchler, who was speaking in Ireland, at Gormanston in Ireland, and what a revelation. He did 4 days of talking about Varroa, which I thought was going to be terrible. But after the 3rd day, we were cheering. And thank you, Ralph, who mentored us for the first part of our project. And we learnt this biotechnical method. I'll show you next, actually. But and we did that to transition away from chemical miticide treatment. So our first year, we didn't put all our colonies in. We put in 28, and we got 26 of those colonies through, and a couple we had queen issues with after the inspections had finished, which was just unlucky. But they were so fresh and well, those bees, in the spring, and there our colony loss. It was one of those fantastic winters where the bees just sitting in deck chairs and having a great time, and we try to compare ourselves to the southeast of England, which seems a reasonable comparator group, and everyone did well there. Only 9% losses, 7% for us, and then what we realised was that if we didn't stop using the biotechnical method, we were just going to substitute the biotechnical method, which was taking the Varroa away very, very efficiently, in the same way that miticide treatments would take the Varroa away. So you in effect had substituted biotechnical for the miticide. So we decided the only way to find if your bees could cope or not was actually to withdraw the biotechnical treatment, and that we did. And it's your 3rd winter, okay, which is the key one. And our 3rd winter of actually, whoa, what did happen then? That's, how do I get that off? Sorry. Where are we? So the 3rd winter of actually having no involvement from the beekeeper was this one here, and that was the only one where we had a 22% loss, which was worse than the. And then in total, we outperformed the regional losses, which is something that you see in the northwest of Wales. There's 500 colonies which outperformed their treated colonies in that part of the world, and also in the Midlands. We're going to show, we've got a big conference on at the weekend where we'll show some of these numbers, and it does seem that bees which have this hygienic behavior have a benefit of more resilience over winter. And there's something in that. They're tougher bees, and they look after the Varroa problem better than us putting toxic insecticides on the bees. So going better than we had feared, and we were biting our nails on the first year. Working as a club. So working as a club is just a brilliant way of helping each other out. And let's just give you some examples of things that we were doing. And we'd really recommend this, working as groups if you can. So we have just set up a new breeding apiary for Varroa-resistant bees. And it's literally last year we were brambles and weeds and trees, and we only have 5 colonies going into winter. We're trying to increase that to 15 hives. It will be the season afterwards and start producing an awful lot of queens, and and that's the plan. And we'll do it on a not-for-profit type pricing. So we encourage people to come to the club to buy their queens, and then we'll spread all those resistant traits out through the area. It will stop people from buying in queens which are mite susceptible. There's too many of those. Here's an example of us just passing the best of our resistant genetics around the area. It's just one particular season, and that goes on every year. Here's a new club project which was set up by a neighbouring club to us. We've been helping them out and doing presentations and things, so they knew what the traits were to look for, and they've set up an apiary just to put their best bees with these traits in. So a treatment-free apiary, if you like, with their best Varroa-resistant traits. And they've got a mixture there of old-fashioned hive called WBCs, a double-walled hive, and polynukes. And there they are. They're in purple here. So this is us in yellow, and they've set up right next to us to see if they can get a benefit from our Varroa-resistant traits. Very sneaky. And we will try and get a benefit from theirs as well. So it's symbiotic. And they've been good. They only started with 3 colonies. They've overwintered last year with 5, so they're in the coming up to their 3rd season. Excuse me. And they even reduced one of the hives. They got rid of one of the colonies which did not come up to the mite levels that they were looking for. So it had too many mites in it, and so they moved it out to a treatment apiary. So did the right thing, kept the ones with the right traits and got rid of the ones without. Well done them. This is a new project just started up, Central Sussex beekeepers who are about 10 kilometres south of us. So we're very keen to help all of the neighbouring clubs to have these Varroa-resistant projects, and we spend a bit of time with them. So this was, I spoke to them last year, and Stephen Martin did as well. We also spoke to them in early January of this year. They then immediately set up a WhatsApp group and started sharing pictures of their Varroa boards, which they'd all gone and put in. Can you see their bits of chewed out pupa exoskeleton on that board? So they're already finding their Varroa winners even before they've opened their hive. So that everyone can do this. Everyone can use these boards. Now, interestingly, this lady who owns this colony hasn't treated for 3 years, and in the past, people were vilified, were laughed at for not treating. They were seen as the villains in the clubs, but now she's the rock star. Everyone wants bees from her, and everyone is full of admiration for her. And interestingly, also, she got her bees from the chair of the club. So the traits are in the area, and they're all looking for them now. So by the time they get to spring, they'll have a pretty good idea of which colonies they're going to be breeding from. Some lessons learned. So things which didn't go as well as they should have done, and hopefully you can learn from this. So mite mutilation and grooming. We were told in all of the scientific literature this was an important trait. It's something that it gets passed around in sort of herd-like mentality, a group think, and it came over from Asia, which is what Apis cerana does. So we spent a lot of time looking at mites and the damage that was done to them and through microscopes and cheering everyone. But this was what was wrong. We couldn't understand this. Here was the mite comparison. So this blue hive here, this is the mite drop for the whole of 2020, the full year, had over 3,000 mite drop. But it was the mite mutilator. We could see There was lots of damaged mites and things, but look at the colonies in the same apiary, the same setup, nowhere near the same number of mites. So there was no correlation at all with this mutilation and idea that they were being groomed off. And the best conclusion that we could come to, that these are mites which are being chewed out and cleaned out of cells, and they're being held by the mandibles of the bees, and in doing so, they damage those mites. They then fall down through an open mesh floor, and then we jump to the wrong conclusion. So we do not look for grooming and mutilation. Do not waste your time with that. It's not a key trait for Apis mellifera bees. Here's was another learning. Try to see Varroa-Resistence as 3 winters of not treating and not being reducing Varroa as a beekeeper. And what happens with mite susceptible colonies, which we talked about earlier, is that the end of year, because there's not enough hygienic behavior, the mite levels are slightly higher than they were at the start, and that carries on going upwards. And you get to a point where the levels of mites and deformed wing virus will overwhelm a colony. And so don't celebrate too much after your first year. Okay, be pleased, but make sure you have a good handle on why those colonies have got through. And if you're finding those traits and the mite levels are low, you can start to get more confident. But 3 years is the bronze medal, 5 is silver, and 10 is gold. We are wary of swarms. Now, it's a bit controversial because some people think they run sustainable colonies by losing half of them every winter, but picking up swarms the next year. We don't see it that way. So our colonies, our apiaries, should be producing a surplus of bees, and there's a danger in taking in mite susceptible swarms. You might be lucky, but most of the time, certainly in the UK, you won't be. They are swarms which will have the low level of hygienic traits, and you do not want them. So you've got options. You can test for the Varroa traits. You know what to look for. You could requeen them straight away. You've got a nice stock of bees there, or you can give them away, to your training apiary or to some beginners, but make sure they're out of area. Now, this is a bit UK centric and probably explains why we went for Brexit, or a lot of people did. So we are trying to avoid imports from different parts of Europe, and this is because we're an island race, I think, partly. But most of these imports are mite susceptible bees. They're not Varroa resistant. They are treated bees with, and they use instrumental insemination to make them. So they won't breed true. They will breed in a very unstable way as soon as they open mate. Now, I know a lot of the ideas between of Varroa-Resistence 2033 will involve instrumental insemination. Good luck. I hope it works for you. It's better to produce Varroa-sensitive hygiene bees using instrumental insemination rather than mite susceptible bees. So, but we try to avoid them. So for bee breeders, we always ask these questions: do you treat your bees, and what levels of Varroa resistance do you see in them? And we get a lot of coughing and spluttering with the answers. Not good enough, bee breeders, and that's true of the UK ones in particular. So we don't like imports. We try to avoid them. The imports, if you're importing Italian bees, they're brilliant in Italy. That's why they are good subspecies of Italian bees, whereas actually the UK ones are more of a central northern European bee, and they're used to that climate. So just use things which work well. The other problem we've had in the UK is that there's so much reliance on imported bees from the breeders in Europe that they actually don't do any breeding themselves now. They just raise bees from what they've imported. And so there's a real loss of expertise, which is a great shame. And I think we'll try and encourage that back into the UK, either by becoming the breeders ourselves and just, again, asking them the right questions. I few notes of caution. Don't think it's cool just to stop treating. There's a few people do that, and you pay a high price. So monitor and be selective. Use the knowledge that you've got, and just be careful with it. I think for new beekeepers, best to learn your bee craft first. We all remember what it was like when we first started, those romantic notions and enthusiasm, and you learn the hard way in beekeeping, and it's best learn your bee craft first and then come to this. And I would say, for smaller beekeepers, a minimum of 3 to 5 colonies is a decent starting number. So if you just have the one colony, just get a local mentor and just take their advice. It's probably not enough. You might be lucky, but it's probably not for you. This was our first year, as a cautious first year, because we were worried about the consequences. If we lost all our bees, it would have been the end of the project, and I would have been flying to South America on a one-way ticket. So this was our first year. So we shook swarm a lot of the bees because there's a big build-up in miticides, particularly if you use thymol-based miticide treatments. So we thought we'd get those out of the wax, but it also took down the Varroa levels, so it gave us an easy first year. And then we came to the summer treatments, which we replaced. This is what we learned from Ralph Buchler, and this is the queen frame trap, which I'm going to show now. Luca's going to do something with the hives. I hope you can see that. So this is one we've made at Western Beekeepers. How to make it is on our website, so you can go and help yourself and have a look. It's bits of queen excluder on both sides. Open it up. There's the frame that goes in the middle. Then you've got some just bits of wood. You've got a piano hinge underneath, which you can buy on eBay. And then we used, our German friends used a couple of screws and some wire, but we used some Velcro, some sticky Velcro across the top there. It all gets properlized out, and the queen goes in there for a period of time. Again, there's some videos and instructions of how we did it. Now you can buy these. These cost you 50 to 60 euros in the shops, or you can make them from bits from eBay. There we are, bits from eBay, and you can make them for about 6 euros, something like that. And I'm the least useful. I'm at DIY. My wife would call me useless, but even I can make these. So they were very useful in our first year, and they are probably the most efficient way of getting rid of Varroa we have ever seen. And we were emailing Ralph Buchler saying, can this be right, Ralph? There's hardly any Varroa coming down. And the answer was yes. This is, I think he said to me, it was German efficiency. And by God, they worked incredibly well, but too much, really. They were too efficient, and they took away the Varroa problem, which is what we wanted to get back to find out which bees could cope and which couldn't. Thank you. Now, the other one there was brood removal, which, again, we've written up in the book. Effectively just taking the brood out, which takes away 70 to 80% of the mites in August. And then you just put drawn comb back in, and the queen starts laying. Takes 10 minutes, very straightforward. And you just need a stock of drawn comb to be able to do that. Very easy to do. They both work very well. Now, the key to our first year was no winter treatment, okay, in the yellow, right? And then that gives you that period of time between sort of August through to next March, where the bees are together for about 7 months with the Varroa. And then you get to, with your monitoring, you then get to find out which colonies have this ability and which ones don't. And sometimes it's going to be relative, but in each case, you're just going to requeen those that haven't got it with those which have. It's simple as that. So there's the summary on getting started. Start cautiously, find your VR winners. Look for the traits that we've talked about. They're pretty easy to see. It's just understanding the biology behind is also straightforward. If you can work as a group and share your best genetics, and if you're in a good group, underwrite your losses. So if someone's going to have a bad time of it, make sure that everyone else agrees to help them out. We believe in locally adapted queens, ones which are used to your local flora, used to your microclimate, used to your local pathogens, and to us there's no better. These are genetic gold. So when some very clever bee breeder tells us he uses instrumental insemination, we run the other way. And then if you can, source Varroa-resistant bees from either someone who has a track record already, or get them from a feral colony, which you know has been surviving year in, year out. So in March, if you know of any feral colonies in trees or old buildings, go and see if they're flying still. And if you can use a bait hive to catch a swarm from there, there's a good chance, because they've already been exposed to natural selection, that they will have the right traits. Some good news is that in the UK anyway, and maybe this will help elsewhere, is that our main educator organisation, the BBKA, has now adopted Varroa-Resistence and put some of the areas of it into their education syllabus from this November. Excuse me. And also, like, the third size organisation called BIBA, which is all about bee improvement, is going to adopt a national strategy to try and get the UK to become fully and sustainably resistant. Now, that's aspirational. It'll take some time, but there's good movement there of institutions which are not known for moving quickly. So we're really pleased with that, and we'll be there to help. But the pace of change is really up to you. You know, it's up to beekeepers. You can make the difference. You can all monitor. You can all find Varroa-resistant traits. You can all ask slightly difficult questions of your bee breeders, and you can all work together to share the best traits and any learning. So it's, you know, over to you in Germany. We're having a go in the UK, and I know there's going to be this big project going across the EU, and good luck. We have written a book on it. Lucas kind of photocopy the pages because it's expensive to post, apparently. I'm sorry about that, to hear that. It is available on Amazon. It's available from Northern Bee Books as the publisher, but you can pick it up through from a lot of the distributors as well. It is in English, I'm afraid, so that's and any royalties for the author is going to Bees for Development charity in Africa. So it's to learn how to do it in a practical way, but has the scientific biology as well, and do some good at the same time. And that's it. Thank you for, hopefully there's some of you online still. Thank you for your interest in joining this evening, and thank you to Luca again for making it all happen. And happy to take any more questions there. Thank you.
Thank you very much for joining us. If I have to say so.
I can't hear you, Ludger. You turn your mic on.
Okay, sorry. Just change something. Okay. Thank you very much for joining us. It's even more important to say I'm coming than my invitation alone wouldn't be sufficient for this evening. And it was very eye-opening for a lot of us, for me, for my audience. I'm just checking if there are more questions. We did a lot of interesting questions already in the first Q&A session. One question: do you have Africanized genetics mixed in your British and Irish bees, like it's the case in the Arnott Forest, where they have Africanized bees from the Middle America projects?
They have a very small percentage, don't they, of Africanized bees? But I was told, I mean, I was in Canada this summer, and I was told by a very good beekeeper out there that the Africanized percentages in the Arnott Forest, and it's the same with a lot of bees in Europe, also have actually come from Tunisia.
Okay.
So there's been a migration of bees. So people see a bit of Apis mellifera and whatever the African subspecies is, and call them Africanized bees, but they're not the Africanized bees that went to Brazil in the laboratory there, and then escaped and come all the way up through South America into the southern states. They actually were part of people importing bees around Europe and North Africa a long, long time ago. So we don't, and we don't see very much, if at all. It's interesting, the South African bees, or in South Africa, the two types of subspecies there do this uncapping and recapping, and they're very, very good at it. And they also do this chewing out of infected pupa. So it's the same traits in South Africa, in the UK. You'll find them throughout the whole of Europe, and in South America, and then in parts of not a few parts of the United States. But it's the problem why we haven't seen them is because we've been breeding from the wrong bees all the time, and not selecting for Varroa resistance, which is something that we can now change. And it's this big concern flying around the internet at the moment about the loss of United States bees. That's not new. You know, they've been getting 40% plus losses for a long time now. And if they only stopped importing, thousands and thousands of mite-susceptible queens from Hawaii, if they turn that into Varroa-sensitive hygiene bees, the problem would be over quite quickly. And let me give one stat. If you look at what happened in Cuba, where the government said we're not treating anymore, and also happened in South Africa, where they couldn't afford to treat, and the style of beekeeping didn't lend itself to treating very well. Fully Varroa-resistant colonies widespread across those countries took between 5 and 8 years. So that's how long Varroa resistance can take. Now, clearly there would be losses if we all stopped treating straight away, but that's the timescale. So here we are, 35 years later, 40 years later in continental Europe, and over 30 years in the UK, still producing the wrong bees. So we have a chance to change that, and there's the time perspective.
Okay, then there is somebody stating you were selecting for color, for phenotype of the bees. What do you actually do this? What is the role of especially the amount of Apis mellifera, mellifera, what we could call dark bee in your project?
Okay, that's new to us. It's a new plan. So we've only been selecting for Varroa-resistant traits at the moment, and we don't care if they're black, grey, yellow, pink, purple. If they're killing Varroa and sorting out their Varroa, they are in, and we love them, right? So and we have the benefit of knowing Stephen Martin, who researches Varroa-resistant traits all around the world, whether he's in Hawaii, Cuba, Mexico, South Africa. And he will tell you that all of the subspecies can do this, whatever their color, whatever their size. Right? It's all about this ability in the to find the Varroa and do the uncapping, recapping, and chewing out process. That's the key mechanism across all these different subspecies. So people get a bit hung up on whether they want carnicas, whether they want some mixed breed called buckfast, whether they want Ligustica or Apis mellifera. We've just set up this new apiary, and we thought, well, why don't we treat? Why don't we try and find the more Apis mellifera bees? And because it feels wrong that we should be losing a subspecies just because we don't care enough about the number of imports. And so that's what we're going to do. We haven't done it yet, but this spring we are going to get them DNA tested. And there's a group in Scotland that will do it for about €60 per bee, and you just do it a bee per hive, and that will give us an indication of the percentage of Apis mellifera and mellifera in the colony, and that's all we're going to do initially. We may go further at another stage, but we just thought we'd try and understand it. I haven't included it in this presentation, but we've got a great slide which shows a very yellow bee from the same colony, and 5 years later from the same colony with 5 years of open mating, and that queen is now incredibly dark. So something is going on, and it feels logical to us that a bee which is native to a country, which is more suited to its climate, will have a natural advantage at some point. We can't prove that at the moment, but it does seem that the bees have got darker. Although it's certainly in the southeast where we are of England, there's a lot of hybridization still. But we don't mind that. As long as the bees are happy, healthy, controlling their own varroa, then that's all okay.
Okay. There's one last question I'm hesitant to put out. Well, we have another 5 minutes. I assume the name Jacques van Alphen says something to you. Can you comment his hypothesis on bee breeding? Perhaps you have first to summarize what he is saying, because most of my audience probably doesn't know his name and what he is saying.
Okay. Jacques actually spoke at the National Honey Show in the UK last October, and the same time as I did. And so we were talking quite similar things, really. But he talks as a higher level biologist, and one of his concerns is that we have lost rare alleles, and so that's parts of the genetic code which can cope with disease. And we've done this because of very narrowly mated queens, which have been using instrumental insemination, which is a really interesting idea that I think people hadn't really thought enough about. So he is a big fan of using the Apis mellifera mellifera dark bee in most parts of Europe, in Central and Northern Europe, and the UK, I would think, as well, because it will have the full selection of capabilities in that bee, as long as it's open mated. And that's what we're seeing as well. So we think with open mating, you get a much better and more stable long-term solution. So in that respect, you know, we're doing exactly the same thing, or very, very similar. And I suspect also that our bees, although not yet tested, but will have a lot more Apis mellifera mellifera now than they would have done at the start of this project.
Without you using color as an additional selection criterion.
We do not discriminate on color.
Okay, so it's a drift you see, but nothing you enforced until now.
Yeah. They have to. Yeah. You know, I don't want yellow bees which can't cope with Varroa, but if they can cope with Varroa, then fine. That's okay. But we don't see yellow bees doing very well in the UK. They do well in Europe. They do well in Italy, which is where they should stay.
My resistant bees tend to be dark also. What is the name of the lab that does the DNA tests in Scotland? You can
I was on a call with them.
You can write me, and I will put it in the German translation of your talk.
I was on a call with them this week. Isn't that terrible? That's the seniority for you.
Actually, same with me. I remember the content of a talk and of a presentation, but I almost immediately forget who is doing it.
Just bear with me a second. I'll see if I can find it. Bee bites. BEEBYTES. One word.
Okay.
Bee bites. And yeah, really good guys. And they'll do whatever you want. So they have a website, and it cost, I think, about €60
per test. Yeah. And the last question, and then we will close the session for today. I think you already answered this, but perhaps for those who joined us later, do you make an interpretation difference in recapping of drone and worker cells? Do you count it differently, and how is your idea about this?
No. We when we first found out about recapping, you do this thing that all beekeepers do, you get a bit overexcited about it. But when we thought about it, we thought actually for a cell to be recapped in a worker cell, it has to be uncapped first. So the uncapping is the search part of the process. The recapping is when there's been a level of inaccuracy, they've made a mistake, and then they come and recap it. So we decided not to look for recapping. It's quite hard to see. And the simple way to do it is to take a picture and then blow it up and have a look. And we do have a picture of some recapping in the book. But we just thought beekeepers aren't going to do this. We need to find things that everyone can do. Everyone on this call can do. And finding recapping is a real waste of time. You should leave that for the scientists. And what the scientists will do is have a little scalpel and they'll dig around the outside of a cell, turn it over, and you'll see on the underside of that cell, you'll see the full silk cocoon if it's not been uncapped and recapped. But if it has been uncapped, you'll see a dark patch in the middle where they've uncapped it and then they re-cemented it in. They remade the cell. And they look at all of these cells for pupa at the pink to purple-eyed stage, and then they will give you a number that says it's 20% recapping, 60% recapping, 80% recapping. And we just thought that is definitely for people who like white coats in a laboratory, but not for beekeepers. And so we do not do it. We look for uncapping, which is sufficient, I think. So just talking about drones, we just see a little bit of uncapping or recapping with drones, and we see a little bit of chewing out with drones. Now, Stephen Martin will tell you that there's no scientific evidence yet that the bees do this, but we will tell him that he's a bit behind the curve and needs to get on and do the research. So it does happen with the more hygienic bees. But just remember, the most important part of Varroa resistance is stopping Varroa from breeding in worker cells, okay? That's what happened. When Varroa came to Europe, it could not believe its luck. All of a sudden, it could breed in all of this worker comb, which was available from January through to December. And in Asia, it wasn't. It was just breeding in the drone cells, which were seasonal. So there was never an issue. So there's your problem. It's the worker brood, where the mites are overbreeding in, and that's where the solution is as well. So when the bee sort out the worker brood, that's what we as beekeepers just need to observe.
How do you integrate the monitoring for uncapping? Do you just do it during your normal inspections, or do you have a fixed schedule? How do you work?
No, just in normal inspections. Because so I already know which of my colonies are uncapping at this time in February. I know that because the ones that find those infected people have chewed it out, and I see it on the board. So I know the process. So once you have the process in your head, seeing the uncapping is very easy to see, and you just know what the biology is, what that interruption process is. But you also know that if you see chewed out pupa on the board, that they had to uncap and find the Varroa offspring and chew that pupa out if it's infected.
Is this a yes or no answer or question, or do you quantize how much of uncapping of chewed out larvae do you find?
So the quantification, this is important because it's really simple, is if there's enough uncapping and chewing out going on because you have a low level of mites.
Okay.
It's as simple as that. Don't overthink it. So in some of my colonies last year, I had someone came down to see me. They traveled 250 or 300 kilometers to see me, and he wanted to have a look at uncapping in the colonies because he'd seen them in the book and presentations. And I went around 3 colonies and I could hardly find any. And the reason for that was two reasons. One, it was right in the middle of the nectar flow, and the bees are doing other things. They're processing nectar and honey. But the other reason was that there was very, very low mites in some of these colonies. So you see less activity. So they don't uncap for fun. So you only see it when they found there's mites there. And then I found one, and beautiful big patches of uncapping. Now, and that's what you should see with bees. They have the ability to find and turn on the solution when the problem is there, when there's Varroa there.
That's it for today. Thank you very much for joining us. Thank you for the input from my head. I have to think a lot now. I'm using instrumental insemination. I'm doing recapping tests and SMR tests. But perhaps, and I know if I want to find a solution for the majority of beekeepers, I need simpler methods. And this is a very interesting and optimistic message you're telling us with this project you have been doing the last years. Next week, I try to translate Stephen Martin's talk. I don't think I can include your talk in this translation next week. This would be a session of three hours if I do the calculation. So Stephen Martin next week in German by me. The week after this and last week in February, Marie Förster will join us to present the Varroa-Resistenz 2033 Projekt. And that should it be for today. Thank you very much. Have a nice evening. Euch auch noch einen schönen Abend. Nächste Woche also meine Übersetzung in Deutsch von Stephen Martins Vortrag. Darauf die Woche die Vorstellung von Marie Förster für das Projekt Varroa-Resistenz 2033. Einen schönen Abend, eine schöne Woche. Ich hoffe, wir sehen uns nächste Woche. Macht's gut.